Hello everyone. So, is there anybody still waiting for somebody to join? I hope I'm going to share my screen and the screen is visible. Somebody came or not? Okay. So my screen is visible and I have to see somebody came. Yes. Ayush. So, hello Ayush. Am I audible? Ayush Ganvir. Okay. So, okay. In this particular lecture, I will be discussing uh, uh, this will be like tutorial session based on whatever content has been taught in the course unit operations for our particulate matter in the first week. So the admit Prince is there. So Prince, am I audible? Prince, and my screen is visible to you. Like I have shared the screen, and I just want to make sure screen is visible or not.
Yes, yes, sir. Completely visible.
Okay, thank you so much. So let's start. Like in this session, we will be solving uh, some questions which will be related to the week one content that has been taught. Can you please mute your
Yes, yes, sir. Sorry.
yeah. So whatever content has been taught in the first week, we will be solving some of the practice kind of question here. Along with that, the numerical practice, like one example for each in the lecture has been already explained. For the centrifugal sedimentation and another one for the first thing. But here we will be having a thorough solution for the same. Question number 12, question number 10, these are the numerical problems involving the concepts that has been taught in the class. And like question number 10, 12, and then further we are having two more questions, 19 and the 22. So these are uh, based on the centrifuge sedimentation and again based on the batch sedimentation. So both will be covered and some small questions which will be like recall for your whatever content you got to taught in the entire week. And sometimes I will be going to the slides of the class itself so that the question and the content can be related. And in meanwhile, whatever doubts you are having, you can pose, you just unmute yourself and then ask question. And like it will be interactive, and we will be discussing as if like some questions you are posing, some questions I am posing, so that the entire conversation goes well. So you have registered for the examination also, or just watching the course? Anybody? Hello. Prince, have you registered for the course and for the examination also?
नहीं सर, अभी एग्जाम के लिए नहीं रजिस्टर किया।
Okay, and hers, what about you? So anyway, you keep solving at the later stage also. Sometimes you feel that now I'm in good condition and I should give the examination. That will be like you will be getting certificate at the end. Then and so week zero assignment and week one assignment is live. So you have gone through that or still solving? Okay, so let me start. So the first question which is here, which among the following is not a unit operation? So which of the following, like distillation, hydrogenation, homogenization, and crystallization? Which of the following is not an uh, unit operation? Anybody? Which of the following is not an unit operation? You can just attempt even it is wrong, no problem. Hmm? So distillation is a mass transfer phenomena. You know that their physical change is happening, like more volatile component is getting separated from the less volatile component, and uh, uh, hydrogenation, wait for that. Crystallization, you know that from the liquid you are crystallizing the solid part, and then that will be separated. Homogenization is a process by which the fat droplet from the milk are emulsified and the cream does not separate. So it this is again the physical phenomena. So distillation, homogenization, and crystallization, these all three are physical phenomena. So distillation, homogenization, homogenation, no, homogenization, and crystallization. Crystallization. Anybody knows about crystallization? You can just write in the chat also if you don't comfort you. Okay, so distillation, homogenization, and crystallization. So what is this? If you actually see, let me explain all the three. Okay, so hers is there. So hers, can you tell me about this crystallization? Anything that you know? Anything that you know about crystallization? So we are solving question number one, and like this is a bit stuck. Yes. Hers, can you say something about you? Like you are BTech, or from where you are doing, or how you came to know about this NPTEL course? Okay, so question number one we are solving. So these three are physical phenomenon, physical change, and hydro. So here, what is this homogeneous distillation is like? Distillation is Distillation is separation based on based on difference in difference in relative volatility of two components or array of components. Homogenization is homogenization is what is homogenization? Homogenization is a process a process by which the fat the fat droplets lets from a from milk are fied, and the cream does not separate, and the cream does not separate. Okay. So after homogenization and pasteurization, milk travels to one of the storage tanks that are there, and the crystallization is, what is crystallization? If you say, so this sugar milk that you are having, they involve crystallization process, and this crystallization process involves like the process by which let me write it down so that things will be more clear. Crystallization, so the process by which the process by which solid forms where the atom or molecule are highly organized into a structure known as crystal, where the atom or molecule are highly organized into a structure known as a crystal. So that is there. So crystal. So now if you see the only remaining option which is a chemical change is hydrogenation. So what is hydrogenation? Hydrogenation, you know that through hydrogenation this vanaspati ghee, these things is made, and hydrogenation uh, is a chemical change. So like hydrogenation is a chemical change. So here if you see this hydrogenation, I will be writing it in different color. This hydrogenation involves removal of addition of hydrogen, H2. So hydrogenation is a a chemical reaction between between a chemical reaction between molecular hydrogen, that is H2, and another another compound compound or or element, usually in the presence of catalysts such as usually in the presence of in the presence of catalyst list such as nickel, palladium, and platinum. This reaction is carrying out. For example, if I want to write a homogenization hydrogenation reaction, it will be like C double bond C H H H H combined with hydrogen in the presence of say PD supported on the carbon base will give ethane. Okay, so ethane from ethene. So this says that this is chemical change. If you write this is chemical change, and these all were physical change. So the option B is correct answer. Hydrogenation is not an unit operation. So option B is correct answer. Option B is correct answer. Okay, so that's all for this question. Now we will move to the second question that is there. So if I see this uh, this another question that is there. This question says success and the failure of the product depends on. So one thing also I want to mention that like why that I just said this physical change and the chemical change is the one that has to be taken into account, and this physical and the chemical change based on that there is the classification that must be followed. If I include that here, suppose this is the question that is here. Okay, this was the question one, and you just solved it no. So just a minute. We will be looking at some important classification. So in the in any suppose chemical engineering is there. Chemical engineering engineering. Okay, so chemical engineering is there, and in the chemical engineering you are having what? You are having this two kind of processes happening. I will be drawing it smoothly. First is the unit operation, and another is the process. Unit process. Okay, and this unit operation will be having what? What? Physical changes. Physical changes. And this unit process will be having chemical changes. Okay, so if you see the further classification will look like the further classification will look like what? You are going down, and then further classification for the unit process will look like mechanical operation, mechanical operation, ration, fluid flow, fluid flow, heat transfer, heat transfer, and mass transfer. Okay, these are the physical changes involved. And further in the mechanical operation section, if you see, if you go further down in the mechanical operation, then what are the main thing that we will be looking at here? What are the main thing that we will be looking at here? That is properties of solid, properties of solid, then size reduction, size reduction, then size separation, that is all about the sedimentation, size separation, size separation, sedimentation comes under this umbrella. Then transportation of solid, where you will be learning about conveyors, transportation of solid, and then mixing. Various mixers are there, etc. And here in the chemical change that I was talking about is the question that had tricked upon. So some examples of the chemical changes which is unit process is is oxidation, oxidation, then hydration, hydration, then hydrogenation, the one which is given in the question, hydrogenation, and then halogenation. Halogen will be there in the at the place of hydrogen, halogenation, then nitration. Okay, so nitration. So that's the one thing that is very important chart that could be used. Uh, Somebody came. Let me allow him admit. And Sri Raj came. So Sri Raj, am I audible? And my screen is visible to you. So the first question that was there is, which among the following is not true, not a unit operation? Distillation, hydrogenation, homogenization, and crystallization. So we came to know that these are the classifications of unit operation, which is the physical change and the chemical change. And in that we came to know that all the processes which were there, distillation, homogenization, and crystallization, they involved the physical change, and only the hydrogenation process, that was the chemical change. So hydrogenation will be the correct option for the given question. So hydrogenation will be the correct answer. Okay, now moving to the next problem. Here, success and the failure of the product depend on. Success and the failure of a product depends upon. So, so flowability of the particle, shape of particle, density of particle, and size of the particle. So if you see in the lecture also somewhere where the importance of size has been discussed, and the example of the chocolate has been taken by the instructor. There you see this 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 is very clear that how much effect of size could lead to the final product. So like if you see the size that was talked about in the lecture, and how the size was playing its role, like all the other options which is there, like flowability of the particle, shape of particle, and the density of the particle, all these factors are anyway related to the size of the particle. So the most important and the controlling parameter here is the size of the particle. So size of the particle is the one on which the product's failure or its success depends. And I will be showing you a like uh, range of the particle diameter in different products. You see, like in the chocolate powder, the size was this. So then only the chocolate will be of that level. In the dried milk also, in the sugar castor also. So so how much important the size is, like in the, you see in the case of wheat, here, so the wheat, from the wheat different thing can be made. From the wheat you'll see semolina, which is sometimes called suji. This is the bigger coarse sized wheat, and this is the flour, that is atta, and then at the end you are having this uh, 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 granite flour, that is maida. So here the basically most of the carbohydrate is there, but in this case protein and the fats and the fibers, vitamins, everything was there. So this 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 size is very important factor, and that controls the overall property and the success and the failure of a product. So the second question that is there will be having, one can claim that the flowability of the particle, shape of the particle, and the density of the particle could be the answer. But in turn you will come to know that these other uh, options anyway depends on the size of the particle. So the main parameter that is the most important in the mechanical operation is the size of the particle. So this is the correct answer for the second problem. And this first problem for the new joinees who came here, uh, let me see whomsoever came. Okay, Bhuana and the Hers is there. So the first problem that was there is, which among the following is not the unit operation, that I explained here very thoroughly. Like this, in the chemical engineering you come to read about two basic things, like unit operation and the unit process. So any reaction that is happening, suppose A gives product B, any reaction that is happening in the chemical reaction in chemical engineering, that involves two things: unit operation and the unit process. Unit operation is having physical changes, and the unit process is having chemical changes. So in the physical changes you are having mechanical operation, and then fluid dynamics, and then heat transfer, and the mass transfer. But in the unit process you are having chemical changes, basically these reactions, and these reactions, basically unit processes are having the chemical reaction engineering and the chemical technology are part of the chemical engineering, and rest is the unit process. And in that, further there will be a division of these things. But if you see in the mass transfer, crystallization comes up. So the option which is there in the which is crystallization, is rejected because it is the physical change. Homogenization is also a mechanical operation process, where I have already told that process by which the fat droplet from the milk are emulsified and the cream does not separate. So that is there. And then if you see this distillation, it is a mass transfer phenomena based on relative volatility, separation is happening, so it is again a physical phenomena. So only the correct winner is not a unit operation, uh, means that is the unit process is the hydrogenation. And the second one, we came to know that success in the failure of the product depends on the size of the particle. So third question which is here, anybody who wants to attempt it. In sedimentation, solid particles are collected, phase separation occurs, both of the above, and none of the above. Anybody who wants to attempt it. In 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 sedimentation, solid particles are collected, phase separation occurs, both of the above, none of the above. Just you look at the question and see if you can get some insight out of this. Like what could be the probable answer of for this one. So basically in all in the all the lectures of the week, you see that there will be like solid particles will be collected anyway. So what is the mechanism for that? Solid particle will be collected, and sometimes there will be different zones like this transition zone, and then a zone rich in clarified liquid, and a zone which is rich in sludge. So sludge will be there. So what is the main thing is like phase separation is happening over there. So if you see in the lecture notes, there you see where this first time introduced to you is the batch sedimentation process. So in the batch sedimentation process, you came to know about this. I will be making it a bit bigger. So in the batch sedimentation, you came to know about the that the in this slurry will be taken in the cylinder, and this is the situation of t equals to 0. The test is conducted under the isothermal condition because temperature also plays the role, because on the temperature various properties depend, like viscosity and the density, and at the same time the surface tension for to sure. And then this sedimentation will have these different zones: zone settling, clarified zone, transition zone, and the compression zone. So these zones will be there. So these zones are nothing but phase separated states. So phase separated states are there, and these phase separated states are actually involving the uh, the entire process and the mechanism of the separation, that is the final need and the final product. So if you see here, initially entire slurry was fed, and with the time what happened, their different zones came up. So zone B, zone A, and zone C is there. So zone A is what? Zone settling, where settling is happening. So here settling was happening completely, but after some time we saw that some of the solid particles started accumulating at the top, bottom, and just above that some less concentration of the particles will be there. That is the transition zone, where uh, both the slurry and the solid particles are there. Both the liquid and the solid particles are there, and in the zone A, zone settling is happening, and B is free from the solid. So B is the clarified zone. And finally, what is going to happen? T infinite means after a long time you will be having completely clarified zone, and only the compression zone. There will not be transition zone, which is C, because after infinite time entire solid particle will be settled, and there will be no such layer which will be having the mixture for the both. So the data is now translated to the continuous process. So first, in order to go for the continuous process, which is very much important when you are going for the large scale involvement of the sedimentation, and as these batch processes are mostly used in the pharma industries, where large amount of the large amount of production is not needed, large amount of sedimentation is not required, like in the case of pharmaceutical things, you are not having that much outlet capacity required, uh, uh, but in the case of other things, this has to be scaled to the large amount. So this particular picture depicts and explains that this this is uh, this is the process by which this phase separation is occurring in the sedimentation. So batch sedimentation is very important for this. And this question, now we came to know that the option B is the correct answer. So For this, option B is correct answer. And this is the size of the particle. So let me somewhat explain more about size of the particle. So this size of the particle is why size of the particle is important, and what is the size of the particle? Anybody anybody like, size is the linear dimension of the particle. For irregular particles, the size may be found as the average of the shortest and the longest dimension of the particle, or as the second largest dimension. So for example, if you are having irregular size particle, then in that case, you will be having so let me explain a bit more about the question number 2, that will be handy to you. So this this question number 2 is size of the particle. So this size of the particle is what? Size is the linear dimension of particle. First is, it is linear linear dimension of the particle, linear dimension of the particle. And second is, uh, for irregular for irregular irregular particles, how we will be defining size then? If the particle size is irregular, the size may be found as average average of the shortest and the longest dimension, shortest and the longest dimension, okay, of the particle, or as second largest dimension, second largest dimension. And if I tell you a clear cut particle size range, so for example, particle size is there, size, and then this unit is there. If you want to know about that, then 1, 2, 3, 4. So somebody came, I think I have to allow him. Yes, Prince is there. So this particle size is like, it can be having its range. For example, if there is coarse particle, and then fine particle, then very fine particle, and then there is ultra fine particle. So coarse particles are having its dimension in inches or in millimeters, mm. And fine is like screen size. So like, there will be sieves in the upcoming classes, you will be knowing getting to know about that. In that, there will be screen size. So whatever the screen size will be there, based on that, the size of the particle will be defined. And very fine is the micrometer and nanometers. And then the surface area per ultra fine particles are being defined as surface area per unit mass. So surface area,
सर
yes.
सर सॉरी टू इंटरप्ट बट आपका वॉइस क्लियर नहीं आ रहा.
अच्छा, एक मिनट, लेट मी सी. Hello, hello. Now it is okay. Okay, okay. Thank you. This was all about this question. Like, the size, why the size of the particle is that important, and it and it actually defines the success and the failure of the product. And in the sedimentation we came to know that the phase separation is happening. So in, I think in the second lecture, sedimentation, batch sedimentation has been explained, and there you came to know that about the various zone like clarifying zone, transition zone, and then the zone which finally you are getting. So the fourth question, anybody want to attempt this? Sedimentation depends on, sedimentation depends on. So what are the various factors that you think that it will depend? For example, pressure, viscosity, shape. So obviously, in the entire calculations that has been performed, we saw that the there you was actually having the effect of size. So it has been explained that the if the particle is large and having low density, or the particle is having high density and its size is low, so based on that two factor, that was the factor that was controlling it. And there you came to know that this size of the particle is playing its role in the rate of the sedimentation, how much time it will take for the settling process to happen. But at the same time, viscosity of the solution, or the 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 liquid in which the solid particles are there, because slurry will be the combination of solid plus the liquid state. So that also defines its role. And also the pressure. So can anybody explain how this pressure is depending on like defining the sedimentation? Anybody if want to try this? Uh, Anyway, this this sedimentation is depending upon these factors. So atmospheric pressure will be there, that will be acting from the top, and that will be anyway having its influence on the entire sedimentation process that will be happening there. So this here all the options will be correct. So option D is correct. D is correct. Okay. So the question number 5, if you see, anybody is there? Uh, Sri Raj is there. Okay. So this free settling occurs when concentration of the slurry is, settling occurs when the concentration of the slurry is. Anybody? Sri Raj, you want to attempt it? Free settling occurs when the concentration of the slurry is. Free settling occurs when the concentration of the slurry is, it is 0.9, 1.2. So in the lecture itself, some where it has been explained that about the free settling, and there you came to know that if something is less than 1%, the concept of less than 1% is very clearly dictated. And there you see this free settling occurs when concentration of slurry is. So this question is straightforward in the sense that this so what is first of all, what is the free settling and the hindered settling? Then the things will be more clear. Sriraj, you want to have you gone through the lectures? Okay, so let me tell you. So free settling is like the solid particles settle under two different conditions. One is the free and the hindered settling. Free settling is like when the concentration of the solid particle in the slurry is very low. Then when these solid particles are actually settling from the top, uh, uh, then if the concentration of the solid particles are very low, they will not feel the influence of other particles which are around them. So like if in the batch settling process lots of particles are poured here, and there is the settling happening, and this is like only very less particles are there. For example, only these three particles are there. Then this particle will not know that whether the other particles are there or not, because there will be no influence of settling of the different other particles in the same settling instrument. So if the concentration of the particles are very high, then there is chances. It's like if the crowd is very much, then you feel very hindered to go to the market, and if it's like very less crowd is there, then you are very free to roam. So it's that is like that only. So if the particle falls in a gravitational field through a stationary fluid, so this is the gravitational field acting, and it is falling, this fluid is stationary in which the settling is happening. Their movement is not affected by the wall of the container. So, so the points are uh, settling under gravity, settling under gravity, okay, and settling under gravity, and again there is uh, 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 the movement is not affected by walls, no effect of wall, okay, and at the same time uh, 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 no effect of other particles, effect of other particles, other particles. If this is like that, and at the same time, if the concentration of the particle, C particle, concentration of the particle is less than 1%, then that is the free settling. This is the case of, this is the case of what? Free settling. Free settling. So now you know that free settling is that. So here only one option is less than 1%, which is this 0.9%. So this is C particle is less than 1% is the correct answer. So for the question 5, option A is correct answer. Option A is correct answer. So now somebody came, or I have to admit Farah. Okay. So this, for the larger height of the sedimenter, you have to see like if the sedimenter height is large. For example, we were talking about like the question about the sedimentation depends on the size of the particle and so on. So this sixth question is like for the large height of the sedimenter, what are the correct choice? First is higher concentration sludge will be found, lesser concentration sludge will be found, concentration of the sludge will not be affected, and none of the above. So so anybody can explain it, like what could be the correct option? Your sedimental height is large, so sedimental height is large means like it's the same that you was reading this batch sedimentation process, and in that batch sedimentation process you came to know about the this. So I have to allow somebody. Sajid came. Yes. Yes. So in the batch sedimentation, you came to know that the height of the column, diameter of the sedimenter, that has been also calculated, and diameter of the sedimenter, this height of the sedimenter, diameter of the sedimenter, and the the overall fluid property and the particle size, all of them are playing its role. So if you see, for the larger height of the sedimentation, what will be the condition? If you are having its size to be high, then what will happen? Your sludge will be found in the higher concentration, in the lesser concentration. Its concentration will be not affected with the height, whether the sedimenter is long or whether the sedimenter is small. So case 1, case 2, what will be the correct answer? Anybody? You just read the question and attempt if you feel like. And these videos will be anyway available on the YouTube, and the links will be shared on the community. And this this entire NPTEL course is a 4 week. In the each week you will be having lectures to be posted on the Swayam portal, and you will be having your these questions assignments coming up there, and you can pose your questions here as well as on the community ask a question section on the website. And then if you feel you can also directly mail to the support team there. So this batch sedimentation test involved the height. So height had its effect. So sludge. So here sludge, the word sludge has been used. So what is this sludge basically? What is this sludge? The sludge is thick, soft, wet mud or similar viscous mixture of a liquid. So if I have to write it for your information so that you can also refer it later, is sludge is SL, sludge is thick, soft, wet mud or a similar viscous mixture of liquid and solid component, especially the product of industrial or refining process. The product of industrial or refining process. So sometimes we call damping of the sewage sludge means lots of the sewage waste that is having particulate matters along with the liquid that are getting damped. So in this, if the height will be more, then there will be more residence time allowed for the sedimentation to happen. So if higher concentration sludge will be found, because at the bottom then you will be having higher concentration, because most of the solid particles will be getting settled then, and there will be uh, more separation. So what will be the take home message here? More height of sedimenter, so more residence time for the sedimentation, more solid settling, more solid settling more solid settling, so more concentration of sludge, more concentration of sludge. Okay, so that's the A option, that is correct answer. So here A option will be the correct answer for the given question. So which of the following is not true for the batch sedimentation test? So test is carried out at a constant temperature. Initially height of compression zone is increases and then decreases. Transition zone stays for longer duration, and none of the above. So which of the following is not true for the batch sedimentation? So this is the situation which is here. So you just attempt this, and this sedimentation process, you see, initially complete slurry was there. There was no separate zones, uh, because still the sedimentation process just started. You see this entire this entire zone of sedimentation uh, is like entire slurry is there, and this slurry at t equals to 0, and at some intermediate time you are looking at, you are saying that some clear liquid started appearing at the top, but here the mix zone is there, and then at the bottom most of the solid particles are being settled. That is nothing but the compression zone, and sludge will be here only, and this is the C, where the transition zone is there. This transition zone appears in the intermittent state between the initial and the long after, means final state. So this transition zone doesn't stay for long. So here you see test is carried out at the constant temperature. This is correct, because why constant temperature? Because on the temperature this density and everything depends. So usually this sedimentation process should be done on the at the relevantly adequate temperature, not very low temperature, because if the temperature is very low, then viscosity will also be very uh, for the low temperature viscosity is very high, and if the viscosity will be very high, then the rate of the sedimentation will be very low. So this, there will be interplay of everything like viscosity, density, temperature, and the residence time that is to be given, and again the height of the column and the diameter of the column, diameter of the sediment. So that will be governing the entire interplay of the sedimentation process. Basically in the sedimentation process, flow past submerged sphere kind of thing is happening, and this entire process is happens at very low, there should not be turbulence. It should be like very low Reynolds number kind of situation. So you see this here, test is carried out at constant temperature. This is correct. So which of the following is not correct? It is said initially height of the compression zone is increases and then decreases. This is the compression zone. So first increases then decreases. This cannot happen. Compression zone height always increases. So this what is this scene here? If you see compression zone height keeps increasing. This is the correct answer for this, and this one is test is carried out at constant temperature. Yes, as viscosity increases if temperature decreases, so difficult settling. Okay. And then this transition zone stays for long. No, no, no. For longer time, there is no transition zone, as this is clear from this particular image we see. For larger time, there will be no transition zones. You see, at T infinite, there is no transition zone. C is completely diminished and deleted. So, so, so this is not true. So, what is the correct answer for this? Transition zone will disappear at T infinity for longer time. So question 7 is done. So this if you see in the critical, so I have to reconnect after some time. Maybe some issue is there. So I will see once it disconnects. So some problem is there with the Google Meet. Okay. So let it happen and I will reconnect the call. So transition zone will be disappearing at the T infinite. So in critical sedimentation time, all particles enter in compression zone, settling zone, disappears, all of the above, none of the above. So in the critical sedimentation time, all particles enter in compression zone, settling zone. What is TC? Critical in the lecture third, I think there has been calculation about the volume of the compression zone and then the critical time calculation for the compression zone, and then some main features of the compression zone. So critical sedimentation time is the one that is required for at least uh, adequate sedimentation, and this critical sedimentation time is actually it depends on what, like this critical sedimentation time, all particle enter in the compression zone. So what is the compression zone? Where all the solids are there. Settling zone disappears, so there will be no settling zone. What is settling zone? This is the settling zone. A is the settling zone, and this is the D is the compression zone. All the particle will come to the compression zone, and then all of the above, none of the above. Which of the following is the correct answer? So sedimentation time is what? Most of the particles that is to be sedimented, they are already sedimented. So the critical sedimentation term, when it first got coined in the lecture, you see this critical sedimentation time. If you see this, there you came to know that, not this one, I think it is in the second lecture of the batch sedimentation, where this TC has been calculated, and that TC will be controlling parameter. So you see this sedimentation happened VL, and this, there you came to know that all the particle when they are in the compression zone and the settling zone disappears, there will be no settling zone when all the particle will be in the compression zone. So these both the option appears to be correct, but what are other feature of the compression zone? If you want to look at that, then this in the lecture only it is given, which is the, no, lecture number 5, no. It's lecture number 3. There is lecture number 3. Yes. Okay, so the critical sedimentation time is all the particle enter in the compression zone. So all the particles are there in the compression zone. All the particles are there in the compression zone. All the particles are there here in the compression zone. Compression zone, and here mostly clarified zone is there. Side zone. No, no transition zone. Transition zone. Again, and one other extra point is that sedimentation is completed. Sedimentation just completed. Sedimentation just completed. So I have to see where continuous sedimentation is used in. Continuous sedimentation is used in where filtration, coal beneficiation, transportation of the solid, and none of the above. So transportation of the solids, for that conveyors are used. Filtration you will be learning in the next week, which is like the coal beneficiation that is there. What is that coal beneficiation? Transportation of the solid is not on the filtration was in the only option that appears to be coal beneficiation. So what is coal beneficiation? Question number 9, if you see. Question number 9, that is, it is coal beneficiation. Coal beneficiation. What is this? So this coal beneficiation, if you see, this involves the concept of this. I will be explaining you coal beneficiation in a minute. So filtration is also a mechanical operation, but here what happens, this is not the continuous sedimentation. There is no continuous sedimentation. Sedimentation. Okay, and then this and then this continuous sedimentation is used in filtration, coal beneficiation, transportation of the solid, none of the above. So coal beneficiation or coal preparation, as it is also termed, refers the organic process through which inorganic impurities are separated from raw mine coal. The organic process, organic process, organic process through which, through which organic process through which organic process through which inorganic 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 impurities impurities are separated from raw mine coal. So it involves the process of sedimentation, thereby providing improved combustion characteristic to the fuel produced. Thereby providing thereby providing improved combustion characteristic characteristics to the fuel produced. Okay, okay. So this is it, and uh, this fuel is there, and then thereby providing this. So option B will be the correct answer for this given question. So option B is the correct answer. Now moving to the, I will be solving this question number 10 and 12 in a minute. Just solve first the smaller questions. Here the separation of the solids is fastest in. So you know that in the lecture also it has been explained that why centrifugation is used. So you see in the lecture, in the centrifugation, what are the advantage of the centrifugation and centrifugal action, that is why the centrifugal action is being used, and why, what are the edges of the centrifugal action over the without involving centrifugal action. So when the centrifugal force are involved in the separation process, gravitational forces are overcome. Thus, the separation efficiency is enhanced significantly. Okay, and the and this here you see the ratio of the centrifugal to the gravitational is very high. Very high means that the separation power of the machine incorporating centrifugal force will be very high, and the separation can be carried out at much rapidly in the centrifugal force than the in the action of the gravity. So the option B is correct answer. And then this question number 13, you see the purpose of the rakes in the sedimentation is. So why the rakes is used in the sedimentation? Anybody? Uh, the rakes are used in the sedimentation for actually these rakes are they actually direct the slug to the center of the tank. So rakes direct the sludge to the center of the tank. That is the one point. And then this rakes are what? These rakes direct the rakes effectively convey settled solid to the center discharge cone or trench. Here, this is the central discharge cone or trench. These rakes direct them to the center. Rakes are constructed in tubular or the structural steel, which rake blades bolted on the welded underneath. So these rakes are very good thing. And then this at the tank center cone or trench scrap attached to the racking assembly keeps the discharge area free from the blockage. So then there is another question that is there, why these cone or trench scrapers are used. uh, they keep the discharge area free from blockage, so that's why they are used. And then tube settlers. So here, this is A option is the correct answer for the question number 13. And then uh, why the feed enters to the tank at a uh, depth from the top. Okay, at a depth from the top. So it is put at a depth from the top. The region is like in order to avoid the turbulence. So if the turbulence will be there, then this turbulence will be anyway causing ineffective uh, settling, and this hence the this turbulence has to be mitigated, and this turbulence will be mitigated only when you are sending this Sending this feed interest to the tank at a depth from the top. Uh, uh, so this has to be kept like like feed enters to the tank. Okay, so 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 it has to be sent to the tank. uh, Wait, so I have to tell you, because to avoid the turbulence. So this is the answer: to remove the sludge, to avoid the turbulence, to hinder the settling. So that cannot be hindered anyway. You are sending when you are pouring it here. So from the height of the tank, you cannot pour. It has to be sent somewhere down below, so that turbulence can be avoided and your feed entered properly. The tube settlers are used when clear liquid is thick sludge is in the desired, both and none of the above. So white tube settlers are used. White tube settlers are used. See, these tube settlers are used when the clear liquid is desired product. So your clarifying tune is the desired product. So when clarification is desired, is desired. Okay. So clarification is the desired thing, then this will be happening. Okay. And now uh, this the concept of the unit operation was first introduced in the literature by. So anybody, the concept of this first introduced by what? William H. Walker, Warren K. Lewis, Arthur D. Little, and William H. McHugh. So if you actually look at the question, this has been told in the lecture also at the very beginning. Arthur was the key player in establishment of the mechanical operation. So this this okay. So this Arthur is the D. Little is the correct scientist for the same who should be credited. And which one of the following is not the synonym of the unit operation? So unit operations are called particular mechanical operation, particulate technology, particle dynamics, and particulate technology. These are synonyms. This is particle dynamics is in the fluid dynamics, so it is not synonym. So this is answer. During flocculation, what happened? In the flocculation, what actually happens is that two small particles clinch together in order to become the larger particle, and then this separation happens. So uh, flocculation is like flocculation is like what? Flocculation is the operation where you are actually combining two small particles. So for what these flocculants do, small these particles were there who used to be sedimented. So they actually cleaved together because of that flocculant, and their size becomes more, their density becomes more, and then they start to settle. So flocculation helps in the settling. So sedimentation process becomes faster because of the flocculants. So now the purpose of the rakes in the sedimentation is direct the sludge. So we have already solved this question somewhere. So 13 question and the 20 question is same. So direct the slush to this. And why feed enters to the tank at depth? Okay, why feed enters to the tank at a depth from the top? To remove the slush easily, to hinder the to avoid the turbulence. So this also we have solved here. To avoid the turbulence, I think. Yes, question number 14. So this 13 14 we have already solved, and you can remove this. So only 20 questions we had. Now let's solve this numerical which is there. Question number 10. This numerical says 300 meter cube per hour of the feed consists of 4% by weight of the coal. Okay, whose specific gravity is 1.3 is to be clarified by the continuous sedimentation. The effluent stream contains 15% of the solid. Okay, 15% of the solid. Okay, so 15% of the solid is there. 15% of the solid is there. Okay, so this uh, this 15% of the solid is there, and this for the following batch sedimentation data that is given here, time and height is given. You have to calculate the effluent condition is to be clarified. Okay, area of the thickener you have to calculate. So no issues here. So area of the thickener, as you know, this area of the thickener could be calculated. So every question we have solved. So this is the question that is there 1.3, and area of the thickener has to be calculated. So you see, using the formula for the CD, what is CD again? This CD is nothing but the the concentration at the base that you was getting, and this CD uh, is the concentration at the bottom, and CF is the concentration of what 4%, consists of 4% by weight of the coal. Okay, so feed concentration. Basically, in the lecture, it has been Ca. So CD and the CF is easy to calculate because here you see this 15% of the solid is there. So 85% of the water will be there. So this is the kg. This is kg per meter cube. This is kg per meter cube. So finally you will be having this is kg and this is kg per meter cube is the density. 1300 is the density as 1.3 is the specific gravity, and for water you know that 1000 is the density. So now you are very clear with this part which is sedimentation. So this sedimentation is clear. This CD and CF you are having 300 meter cube per hour is the Q which is given here, and F and D are the two values which are there. So we will see what are they. So this, when you plot this height versus the time which is given here, the height of the interface and the time, you will get this curve. Height versus time is this curve. Okay, this curve is height versus time and this height versus time curve, from here it is clear. You got CD, you got CF value. Now this height versus time curve is there, and then this height versus time curve From here you calculate the CL. CL is what? CL is what? The the zone where it is not at the bottom but at the intermittent state. So this CL can be calculated using the H0 and the HI. HI any intermediate height that has to be calculated over there. And then the expression for LCL by AR equals to X upon 1 upon CL minus 1 by CD. This is the sedimentation velocity, and AR is the area of the sediment that has to be calculated. So when this will be very low, area will be very high. So we have to minimize this function. Okay, so how we will be minimizing it? We will be plotting the graph for LCL by AR, and then we will be looking at what is the minima for this. When this will be minima corresponding to that value of X, you will be having AR to be maximum, which is the diameter of the sedimentation process. So you had T, you had H for slopes. From the slope you see, so this T time and the height you had, and this this slope dz by dt has been calculated. That is nothing but dh by dt has been calculated at different points. This has been calculated. So when you have dh by dt, so you are having x. So this CL could be calculated based on that. CL is calculated like this, and this is exactly same as the example that has been discussed in the class. And so LCL by AR is calculated. So here LCL by AR is having the minimum value of 1.194. 1.194 is the minimum value of LCL by AR. And from here you see this Q is 300, and if you incorporate the various factors like the the which is given here, you see, to at the time 200, this is 20, and this for the slopes they have taken the value to be at equals to 10, equals to 20. This chart is very important. This will be much easier if you are solving it on the Excel. And then we know that Q by AR this at this minimum, and correspondingly if you calculate AR to be Q upon small this 300 divided by 1.194, you will be getting Q equals AR equals to 169.034. So 169.034 is the choice. 169.034 is the correct answer. So option A is the correct answer for the given question. So this is clear from the given so you see this is a similar example has been explained in the class also, and there you came to know that this height of the interface is the factor that was uh, playing its role, and that has been used in the calculation of the first the area, uh, and that came from the minimization of the of what of your this LCL by AR. So LCL by AR, Q by AR, from there you calculated AR, and this was the curve for LCL by AR that can be plotted, but in our case we have directly saw that this that 1.9 was the value which was the largest value for the same. Okay, so this is the 1.194. Okay, and now if you see this, when you see this question number 12. So this is similar example is also there in the lecture. This is very straightforward question. So you look at this, you read, and we will be solving it in it soon. You read it. So if you actually go to the this class example, then the things will be a bit more clear because there you have got the thorough explanation of the each terms and the units and the symbols and how each quantities has been calculated. So I encourage you to go for that to get the clear understanding of the same. And now we will be moving towards the next this 12th question. So 12th question is like a centrifuge having diameter and a height of 50 centimeter and 1 meter respectively is being operated at 1000 rpm. 5 centimeter thick liquid layer is formed inside the bowl. Computed the volumetric flow rate of the slurry if 80% of the particle can be separated in the this centrifuge. Hmm. Hmm. With the volumetric flow rate of the slurry if the 80% of the particles can be separated in the this centrifuge. Okay, so in order to solve this question you need to be, this is the question uh, that is there, this one, a centrifuge having diameter and the height as the 50 centimeter and 1 meter respectively is being operated at the 1000 rpm. 5 centimeter thick liquid layer is formed inside the bowl. Compute the volumetric flow rate of the slurry if 80% of the particle can be separated in this centrifuge. Specifications like density of the solid particle 2500 kg per meter cube, density of the liquid is 1.2 kg per meter cube, viscosity of the liquid is this, the particle size distribution is given, then you are asked to calculate the volumetric flow rate. So if you see the given data is that height is given 1 meter, radius is given 0.25. So height and the radius is given. 0.25 is the radius as the diameter is given to be 50 centimeter. So it has been converted to the meter. Density of the solid particle is given to be 2500. and density of the liquid is given to be 1.2 kg per meter cube, and viscosity of the fluid is given to be 0.0032 kg per meter second. So from here it is clear that uh, the uh, it is clear that this uh, omega equals to 2 pi 1000 per 60 equals to 104.72. This so omega has is to be seen here. It is given that the R0 is 25 minus 5. It is to be calculated because 5 is what? So this R0 is the parameter which will be coming up in the equation. So this 25 centimeter is the complete radius, and 5 centimeter is what? Is the thick layer. So this if you see this 25 centimeter, this this layer is there. I cannot write it here, so I will be using this. Oh, no. Okay. Mm. Okay, so let me restart it so that things become easy to your side. And this you see uh, is the explanation for the question here. See, so we were here, and I wanted to have this explanation notes. Okay, so no issues here. Yes, now I can use the pen. So this you are having, this is the centrifuge which is rotating, and this is the thick section. It has been given that this is the radius is r is the 5 centimeter, 25 centimeter. So and this is thick zone, this is 5 centimeter. So that will be this difference will be what? 20 centimeter is this difference. This is r0. Okay, and this omega equals to 2 pi into 1000. Okay, 1000 is the rpm which is given in the question, that at this rpm your centrifugation is happening, and 80% of the particle can be separated in this centrifuge. So this they have completed repetitions per second in order to make sure that unit is consistent. And this is what sieve. So like this has been calculated to what is happening. So these are the largest particle, so this will be correspondingly one. And if very small particle, so this is like 0.03. Cumulative mass has been calculated, so this is nothing but the addition of the two which is at the bottom. So you see, if you add 0.07 with 0.03 added by 0.07 gives 0.01, 0.1. So this is the bottom one. And this, when you add all these three, 23, then third one will be 2 3 So this is completed. When you add all the three, you will be getting one here. So one came here. So now it is very much clear that cumulative and the particle size has been calculated, and you plotted these two cumulative particle with the size. And here it is said that 80% of the particle. It is very important line that 80% of the particle can be separated in this centrifuge. Then what is the volumetric flow rate? So for the 80% particle to be separated in the centrifuge, if you see, for the 80% particle to be separated in the centrifuge, here here centrifuge, what is the particle size required is for the 80% particle to be separated in the centrifuge. The particle size range that is there is for from the graph for 20% mass fraction. The cutoff diameter has been calculated to be 0.1 mm. So whatever will be larger than this, they will be separated. There will be no issue in that. So as the particle are fine in the size, uh, laminar zone can be assumed. So for the laminar zone, we had this expression for the value of volumetric flow rate cutoff. And when you incorporate all the value, you know R, you know R0, you know omega, you know dpc. Dpc is like 0.1 mm. And rho s, you know rho f, you know mu f, you know b is the height of the tower. Everything you know. And you when incorporated, you will get 3.2 to be the correct answer. So option B is the correct option for the given question. So option B is correct answer for the given problem. So what is the correct answer here? 4.3.2. 3.2 is the correct answer. So here you see this 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 is the question that is there is there is a bit change in the options, I think. In the question, this is the correct question. Okay, so 51 and 1 5 centimeter. Let me just check it. Compute 80% to, okay. So this, when you solve it, the options should have been, this is like what? This is like 2.58, 5.67, 3.2, and 6.76 meter cube per second. Okay, meter cube per second in all the three. And this is the correct answer. So 3.2 is the correct answer for the given question. So you got it. And this is last two questions are very similar to the questions that we already discussed. And I will be telling you question number 22. You can solve this question number 19 from yourself. This is very easy one, and I can show the solution for this if you need, so that when you are solving from your own, if you feel some if you struggle with this, then there will be no problem from your side. And the questions that is of your relevance is easy to solve. So if you see this question, this 2500 meter cube per hour of the feed, consisting of the 3% of what weight of the coal, which is having a specific gravity of 1.3, is to be clarified using the continuous. The effluent stream consists of the 12% of what solid. For the following batch sedimentation data, find the area of the thickener. So here also area of the thickener is asked. So as I explained in the previous question, you have to calculate the CD, you have to calculate the CF, you plot time versus height. Time versus height has been plotted, different slopes. So based on different slope, you make this table, and in this table you look at where is the lowest value of LCL by AR, and that is the lowest value of LCL by AR corresponding to which you will be having highest area. So this Q has been converted into the units, and there at the layer, it is not at the bottom, but where the just this compression zone is starting. And based on that, the QAR by AR can be calculated to be the minimum value of LCL by AR to be 0.95, and the corresponding area value is 13.132.32. So option A is the correct answer for the same. And now this one, this we have solved it. This is the direct slush, and here this drop, this provide turbulence. And the last question of this lecture is this one. So you attempt this question, and then we will be going for this for the explanation for the same. You just attempt this, and I will be joining in a minute. Attempt the question, and we will see if this actually clears up. So 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 this is very important from the side of uh, this course, that you go through the lectures that are being taught, you watch them at your pace, and then things will be more clear to your side. So you solve the question is this one. So as far as I think, you have read through the question, and this 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 particular question is based on centrifugal action in the sedimentation which is happening. So here again, uh, all the values like this, you see, these values are again given, and this particular question is what you need to be actually looking at. So this, you see this, the options that are there, 0.2.58, anybody have solved, or yet still trying? So you need to be ready with the calculator when you are going for this particular problem, because it involves. So what are the things given over here is the given data are what you are having the value of b to be 1 meter, and then the r, which is like 0.25 meters. Okay, and then you are given with the density of the solid to be 2000 kg per meter cube. Density of the fluid is given as 1.2 kg per meter cube, and viscosity of the fluid is given as 0.0032. kg per meter second. So if this is the case, then then the RO value is what? RO, the thing that I have already explained in the lecture, that this is the centrifugation happening and this is the zone. So this is the RO, means R minus thicker. This is thickness RT. So this will be RO equals to 25 minus 7. As in the question it is said that 7 centimeter thick layer is formed inside the bowl. So this will be what? 18 centimeter, means 0.18 meters. And omega equals to 2 pi 1200 into 60. Actually in the RPS is revolution per second is calculated. So here the 80% of the particle can be separated in this centrifugation, it is given. So as 80% of the particle is separated in this centrifugation. So this data is will be used in order to get the cutoff diameter. So the cutoff diameter calculation I will be showing up here is this. Uh, you had all the values over here, and the cutoff diameter value, the cutoff diameter value is this, that you will get, uh, and this data which is there will be used to plot the cumulative mass fraction 2 versus the particle size. And when you once you plot it, cumulative mass fraction versus the particle size, then you will come to know what is the cutoff diameter above which all the particles will be sedimented, and that will be the deciding factor for the efficiency of the sedimentation process that is there. So from the graph, for 20% mass fraction, means 80% of the particle is separated, uh, uh, the cutoff diameter is 0.087. So this 0.087 mm cutoff diameter will be the value corresponding to which, using the cutoff volumetric flow rate expression corresponding to the cutoff diameter, the cutoff volumetric flow rate can be calculated. That is asked in the question. You see, the question has asked us that the question has asked that the the volumetric flow rate of slurry if 80% of the particle can be separated in this continuous centrifugation process. So this is very clear from this discussion that the continuous fugation process will involve this particular uh, uh, thing, like this Q can be calculated using pi times height. This is there in the lecture. Rho solid minus rho fluid, omega squared dpc, cutoff diameter of the particle divided by 18 mu f, and this will be again used as what? As what? R square minus r0 square divided by ln 2r divided by r plus r0. Okay, ready with this. So now when you put and substitute all the values over there, along with that DPC value you got to be 0.087 from the graph which is shown here. You get the value to be QC equals to 2.6 meter cube per second. So QC equals to 2.6 meter per second is the question. That is that will be the answer for the question. So if you see this, you will be getting this. And this question is like what? First option is the correct answer. So the take home message for the today's class is that uh, we solved like 20 to 22 questions that involve the concepts uh, of the batch sedimentation, centrifugal sedimentation, and the basic introduction to the unit operation of the particulate matter, which is also called the mechanical operation. And there you came to know that the various we have solved four numerical problem. I have shown you the solution and also solved along with you. And then this theoretical questions that were somewhere in the lecture discussion and in some standard books that has been kept in the reference of the content of the course. And this is all for today's lecture. I hope you all are good. Thank you. Thank you so much. Thank you. So, okay. Okay.